Previously, we found that x is equal to cosine of theta and y equals sine of theta. So if we look on the unit circle at each of these points here, every x and y on the unit circle is equal to cosine of theta, comma, sine of theta. So looking at tangent, we can rewrite it as tangent of theta. We know that it's equal to y over x. But knowing that y is equal to sine and x equals cosine, tangent of theta can also be rewritten as sine of theta over cosine of theta. So essentially, we end up saying that tangent of theta is equal to sine of theta over cosine of theta. Let's take a look at how we use the unit circle to evaluate sine, cosine, and tangent of these points. Hi y'all! So for these examples, we're actually going to find all three trig ratios, sine, cosine, and tangent, of each given angle. So the first angle we have here is 5 pi over 3. Okay, so just as a quick reminder, whenever we see something like sine of theta, cosine of theta, tangent of theta, theta is represented by that angle. So in this case, 5 pi over 3 equals theta. Okay? All right. Now, what we've seen is if you look at each x, y coordinate, so in our unit circle, everything that looks like this on the outside of our circle, referring to each of these points here. This can be rewritten as cosine of theta, comma, sine of theta. Okay. All right. So if we look at the angle 5 pi over 3. Okay, so on our unit circle, 5 pi over 3 is all the way down here. Okay. So now our focus is on this point. The point that associates with 5 pi over 3 is 1/2 comma negative root 3 over 2. All right. Now, since we have this point, we can say that cosine of 5 pi over 3 is going to equal to the x value, which is 1/2. And sine of 5 pi over 3 is equal to the y value, which is negative root 3 over 2. Awesome. So what just happened? Looking at this coordinate point, x comma y, that gives us cosine of our angle and sine of our angle. So the only remaining thing we need to find is now tangent of 5 pi over 3. When we do this, we're going to use that equivalence, that tangent is equal to sine of 5 pi over 3, I'm just going to write theta here, over cosine of 5 pi over 3, theta. All right. So I'm just going to scoot it down a little bit. Here, we can sort of ignore the unit circle. Now we're just going to compute. So sine of theta is negative root 3 over 2. And we're going to divide this by cosine of theta, which is 1/2. All right, let me scoot it on over really quick. Okay, so here we go. Here's the fun part. In order to divide 1/2, we'll just multiply root 3 over 2, or sorry, negative root 3 over 2 times the reciprocal of 1/2, which is just 2 over 1. Okay. Now you could probably already see it, but let me just write it out. I'm going to multiply across. So we get negative root 3 times 2 is the same thing as negative 2 root 3 divided by 2 times 1 gives us 2 in the denominator. Okay. Now look at this. Look at this. 2 over 2, that can simplify. They basically cancel each other out. Boom, boom, it turns into a 1. So our final answer is tangent of 5 pi over 3 is equal to negative square root of 3. Yahoo! So we found tangent of 5 pi over 3, sine of 5 pi over 3, and cosine of 5 pi over 3 using our unit circle. Okay, that one was pretty fun. Let's look at the next example. We're going to find the 3 trig ratios for 7 pi over 6. All right, so again, we know that 7 pi over 6 is the theta. It's the angle in our function. All right, so we know that we can rewrite each point as cosine of theta, comma sine of theta. So if we first find our angle, 7 pi over 6, on our unit circle, it's going to be all the way over here. That means we're going to pay attention to this point here, negative root 3 over 2, comma, negative 1/2. Okie dokes. So from these points, we can obtain cosine and sine of theta. So we say cosine of 7 pi over 6 is equal to the x value, negative root 3 over 2. And sine of 7 pi over 6 is equal to the y value, or negative 1/2. Yay! Okay, so we took care of 2 out of 3 of our trig ratios. All that's left to do is figure out what is tangent of 7 pi over 6. Okay, so tangent of 7 pi over 6, this is given by sine of 7 pi over 6 over, or divided by, cosine of 7 pi over 6. These two values were figured out in the previous step. So all we have to do is plug it in. So sine of 7 pi over 6 is negative 1/2. And we're going to divide that by cosine of 7 pi over 6, which is equal to negative root 3 over 2. Cool beans. Okay, so let's go ahead and multiply this out, right? We're going to take negative 1/2. And dividing by negative root 3 over 2 is the same thing as multiplying by its reciprocal. So we're going to multiply it by 2 over negative root 3. Okay, so just as a side note, it doesn't really matter where your negative symbol is placed, whether it's in the numerator, denominator, or right in the middle. Okay, as long as there's just one, then you know it's going to be a negative number. All right. So here we go. Let's multiply across here. So in our numerator, we get negative 1 times 2 is negative 2. And 2 times negative root 3 gives us negative 2 root 3. Okay, so there's like an invisible multiplication symbol here. Just want to point that out, okay? All right, now let's simplify. You probably notice we have negative 2 over negative 2. So that means those two will cancel out, including the negative symbol. That will turn into a positive. Wow. So when we canceled those out, that turned into a 1. So the 1 goes in our numerator, and we're left with root 3 in our denominator. Ah, so close. We just have to rationalize that denominator, get rid of that radical. So we're going to take root 3, multiply it to our numerator, multiply it to our denominator, and our final answer gives us root 3 over 3. Okay, so we get tangent of 7 pi over 6 is equal to root 3 over 3. So as you can see, cosine and sine are obtained directly from the unit circle, whereas tangent is obtained from sine and cosine. So we have to find these two first before we can figure out tangent, do a little bit of algebra, and we end up with our final answer here.